So for number 18, we're supposed to solve the following exponential equations, show your results in terms of logarithms, and so what I mean by there is exact answers, then show your result rounded to the thousandths place. So a problem like this, you can write with a common base. So you don't have to take the natural log of both sides on this problem, although you can, and I can show you that. But you could also write this with a common base. So what I mean is you have 2 to the 4x minus 2. The 64 can be written as 2 to the 6th power, because 2 to the 6th is 64. Now, when you have a common base, then you can set the exponents equal to each other and solve that equation. So in this case, we can add 2 to both sides of the equation. Got 4x is equal to 8. Divide each side by 4, and you get x is equal to 2. No rounding required. Now, if you decide to solve this using the methods that we talked about, where you take the natural log of both sides, that's perfectly okay too. And let me show you that. So first step is to get the exponential function or expression by itself, and it is already. Okay, then you take the natural log of the left side, and you must take the natural log of the right side as well. The whole point of doing that is so you can move that exponent in front. Be sure to put parentheses, I wrote it backwards, around your exponent, especially if it's more than one term, like 4x minus 2. Okay, now the goal is to get the x by itself. This is the only x in the equation, so there's no need to distribute the natural log of 2 inside. So I'm going to divide both sides by the natural log of 2. Okay, natural log of 2 cancels. I wrote a line I didn't need. You have 4x minus 2 is equal to the natural log of 64 divided by the natural log of 2. I'm going to add 2 to both sides next. So I have 4x is equal to the natural log of 64 divided by the natural log of 2 plus 2. And then the last step, divide both sides by 4. So it's going to give me x is equal to the natural log of 64 divided by the natural log of 2 plus 2 all over 4. Now that's an exact answer, but the problem is it's not simplified. The natural log of 64 divided by the natural log of 2 simplifies a great deal. Then you add 2, then you divide by 4, and you should get 2 when you do that. I'm going to check it on my calculator just to be sure. So you know when you type in a natural log in the calculator, what happens is a parenthesis pops up here. You're going to have to close out that parenthesis. Same thing when you divide, and a parenthesis will pop up here and close out that parenthesis. So when I do the natural log of 64, close out the parenthesis, divided by the natural log of 2, close out the parenthesis, that gives me 6. I'm going to add 2 to that, which gives me 8, and divide by 4, which of course is going to give me 2. So that does give me an answer of 2 like we got. So really you can do it either way, but if you can rewrite with a common base, that really is the simplest way to go for a problem like that. For problem B, this is another one that you can rewrite with a common base. 125 and 25 can actually be written with a base 5. So 125 is 5 to the 3rd power. And notice there's an x as an exponent. There's still an x as an exponent. And 25, on the other hand, is 5 to the 2nd power. Now, whenever you have a power raised to a power, you should multiply those together. I didn't know that highlighter was going to be set so small. Sorry. There we go. So that's going to give me 5 to the 3x is equal to 5 to the 2nd power. Once those bases match, you have 3x is equal to 2. I divide both sides by 3, and I get x is equal to 2/3. That's my answer. That's my exact answer. There's no need to type that in a calculator. But you could take the natural log of both sides and solve that as well, like we did A. But since I have an answer, I'm not going to do it that way. Okay, next problem. Can I write 7,000 as a base 10? I can't. I can write 1,000 as a base 10, but not 7,000. So this problem, we do need to evaluate the natural log of both sides. So you have natural log of 10 to the x is equal to the natural log of 7,000. All right. then move that x in the front. That's the entire reason we evaluated the natural log of both sides. And by the way, if you ever see this solved a different way, and somebody doesn't use a natural log, they use, say, log, in this case, that would have worked just fine. It would have been a little bit easier. But I'm trying to be consistent in what I'm showing you, something that works every single time. And so that's why I'm using the natural log every time. So the natural log of 7,000 divided by the natural log of 10. And I type that in my calculator. So the natural log of 7,000, make sure you close out the parenthesis, divided by the natural log of 10, also close those out. And that gives me an approximate answer of 3.8451. I'm going to go ahead and round everything to 4 decimal places. I said the thousandths place, so how about 3.845? There we go. I got to read my own directions right there, thousandths place. 3.845. For problem D, now this is another problem that can be written with a common base. 9 and 27 can be written with a base 3. So I can write 9 as 3 to the second power. Now that exponent of x plus 2 is still there. On the right, I can write 27 as 3 to the third power, and that exponent of negative x is also still there. Now, when you have, again, a power raised to a power, this is a multiplication problem, and this is a multiplication problem. So here we've got to distribute the 2 inside. So that's going to be 3 to the 2x plus 4. Fix that x. And over here is going to be 3 to the negative 3x. Again, so notice my bases match. My exponents are simplified, so it's time to set the exponent on the left equal to the exponent on the right. Solving for x, so let's get all our x's on the same side. I could just subtract 2x over here. I could add 3x and divide by 4 and make it a two-step problem. Let's just subtract 2x. So that gives me 4 is still on the left, negative 5x is on the right. I divide both sides by negative 5, and I get x is negative 4/5. Now I did say that you should round to the thousandths place, although a fraction in lowest terms is perfectly appropriate, but also you could write that as negative 0.8. No need to round to the thousandths place. Question E, now I have no idea if you can write 8 and 12,143. Well, yeah, I do, because 12,143 is an odd number, so you couldn't write it as a base 2. But even if I wasn't sure, then the natural log step that we've talked about would work. So don't waste your time worrying about it. If you don't know, just take the natural log of both sides. Once the exponential is isolated, and it is, the next step is to move that x in front. So you have x times the natural log of 8 is equal to the natural log of 12,143. Let's divide both sides by the natural log of 8 to get the x by itself. Okay, so divide this side by the natural log of 8 and divide this side by the natural log of 8. Notice the parentheses. Why the parentheses? Just so I can type it in my calculator without any trouble. So natural log of 12,143 divided by the natural log of 8 is my exact answer. Now I'm typing it in. Close out that parentheses. That's really important. And I get 4.5226, and it keeps going, but remember, round to the thousandths place, so 4.523. And again, that's my approximation, whereas this is my exact answer. Now to deal with example F, you'll notice your exponential function is not isolated. I can divide both sides by 9, and I should before I get started. So if I divide the left side by 9 and divide the right side by 9, I have e to the 5x is equal to 1,269 divided by 9. Now I don't even know if 9 divides into 1,269. I could check. Oh, it does, 141. Or I could have just left it like that and simplified later. Now, I need to solve for x it's in an exponent. Remember, the next step is to take the natural log of both sides. So I have the natural log of e to the 5x is equal to the natural log of 141. You can throw parentheses around that 141 if you like. Now, it's two ways to think about what we've got going over here. Okay? You can think the natural log and the e cancel each other, or you can think you need to move that 5x in the front. Either way is fine, because the natural log of e, it does cancel each other out. You'll have to recognize it before or after, and that's just going to give you 5x. So I have 5x equals the natural log of 141. Trying to solve for x, so let's divide each side by 5. And there's my exact answer, natural log of 141 divided by 5. Then I just plug it in my calculator to approximate. Typed it in wrong. Bear with me a minute. And I get 0.98. Then 975. I wrote all that so we could talk about rounding, because this is, of course, the thousandths place, but that rounds up, which makes that one round up. 0.990 is my approximate answer there. So, for example, G, we have e to the 12 minus 5x minus 7 equals 123. Remember, your goal, first step, is to isolate the exponential part. All of this is the exponential part. The minus 7 is not part of that. So my first step is to add 7 to both sides of the equation. Now I have e to the 12 minus 5x is equal to, notice those 7's cancel, 123 plus 7 is 130. So now it's time to write the natural log on both sides of the equation. So we're evaluating the natural log of both sides. Now what's great is whenever you have a natural log and an e, you know those cancel each other out. And now I get 12 minus 5x, but it's no longer an exponent, and now it's normal level, equals the natural log of, I like parentheses, 130. Now your goal is to solve for x. So let's get this x by itself by subtracting 12 from both sides of this equation. So I have negative 5x is equal to, now you can't subtract 12 from 130 because it's within the natural log. You may just want to write down the natural log of 130 minus 12. That's the best way to go. Next step, divide each side, the entire side, by negative 5. So my exact answer is the natural log of 130 minus 12 divided by negative 5. Now, we don't like negatives in the denominator. So if you want to take that up to the numerator, what it's going to do is it's going to make that natural log negative and that negative 12 positive. So I'm going to put the 12 first and then write the minus natural log of 130 divided by 5. That just looks cleaner. And then for a decimal approximation, you do 12 minus the natural log of 130. Again, be sure to close out those parentheses. I'm going to push equals first, which is 7.132, and then divide by 5 with that in my calculator. And I've got 1.426 when I round to the thousandths place. Example H, 5 to the 4x plus 2 equals 37,500. So we're supposed to get the exponential part by itself. Look, it is. 5 to the 4x plus 2 is completely isolated. So now I'm ready to evaluate the natural log of both sides. So the natural log of 5 to the 4x plus 2 is equal to the natural log of 37,500. Move that 4x plus 2 to the front. So now I have 4x plus 2 in parentheses times the natural log of 5 equals the natural log of 37,500. All right, now my goal is to solve for this x. You know, if you have to highlight it just to keep up with it, that's the guy I'm trying to solve for. Now, there's not x's on both sides of this equation, so there's no need to distribute the natural log of 5 inside. Let's just divide by it. So divide by natural log of 5, so it cancels here, but you also have to divide by it on the right. Now I have the equation 4x plus 2 is equal to the natural log of 37,500 divided by the natural log of 5. Let's subtract 2 from both sides, right? So now I have 4x equals the natural log of 37,500 divided by the natural log of 5 minus 2. Last step, divide everything by 4. Divide this by 4 and that entire side by 4. So the exact answer is really ugly. The natural log of 37,500 over the natural log of 5 minus 2 over 4. That likely could be simplified, but I'm not going to get into all that because we're just going to type it in our calculator anyway. So just be careful when you type this in your calculator. So I've got the natural log of 37,500 first. Close out the parentheses divided by the natural log of 5. And close out those parentheses. Go ahead and push enter and you get 6.54. Then minus 2. Push enter again and then divide by 4. And that way you're certain you're following order of operations. So x is approximately 1.136. And then there's my exact answer. Now for our last problem number 18, solving exponentials, you've got two different exponentials. And they are each on their respective sides isolated already. So it's time to evaluate the natural log of each side. So the natural log of 3 to the x plus 4 is equal to the natural log of 7 to the 2x minus 1. The reason we did that is so we can move those exponents in front of the logarithm. So parentheses x plus 4 times, almost lost my natural log, times the natural log of 3 is equal to 2x minus 1 times the natural log of 7. Now let's distribute. So you have x times the natural log of 3 plus 4 times the natural log of 3. And you know what? Why did I distribute this time when usually I just divided by the natural log of 3? Because there's x's on both sides of the equation. And in that case, you've got to distribute so you can collect all of your x's on one side. Okay, so we'll do the same thing on the right. I have 2 times the natural log of 7x minus the natural log of 7. Again, I'm taking that whole thing times 2x, and then that whole thing times negative 1. Now, look, this term has an x in it, and this term has an x in it. Let's move all those to the left side, and then the ones I don't have highlighted, let's have those on the right side. So I have x times the natural log of 3 minus 2 times the natural log of 7x. Now I'm not being consistent with my x's. Let's put the x here and then the natural log of 7 in the back. You want to do that? Equals, now over here I have negative natural log of 7, and I'm going to move this one, so I'm going to change the sign, minus 4 natural log of 3. And if you want to put parentheses around the inside of what's in a natural log, that might be a little easier to look at. Now here's what you have to do, because you have an x in both of these terms, you must factor that out. So that gives me natural log of 3 minus 2 natural log of 7. On the other side I have negative natural log of 7 minus 4 natural log of 3. The last step, y'all, is to divide by this big term in parentheses here. So I have x, or expression really, equals, now I'm rewriting the left side with all those negatives, negative natural log of 7 minus 4 natural log of 3 divided by all this that's in parentheses. So natural log of 3 minus 2 natural log of 7. That is an exact answer. Then when I type that in my calculator, I'm going to do negative and then have natural log 7, close out the parentheses, minus 4, then I have natural log of 3, close out the parentheses. Go ahead and enter that in your calculator. By the way, it's negative 6.34. Divided by, now look, you're going to have to put a big set of parentheses around this entire denominator so you can divide all of that numerator by those two terms. So I have parenthesis, natural log of 3, close out the parenthesis, minus 2, natural log of 7, close out that parenthesis, and then I have the extra parenthesis that was in pink there. And that gives me a final result of 2.26 99, and it keeps going. Remember, we're trying to round to the thousandths place. So that's not the thousandths place. That's the thousandths place, right? So that's going to go up to a 10 to make that a 7. So 2.270 is the thousandths place. Okay, now let's try some logarithm problems. So here we are. Let's solve some logarithmic equations. Now the first step is to isolate the logarithm. Okay, so you've got to do that first. Notice our logarithm is isolated. It's got a lot going on inside the logarithm, but we can't do anything with that 5 or that 3 because it's inside the logarithm function. Now there are different ways to handle this, different methods, different books do it different ways, but I have decided my favorite method is to rewrite this in exponential form. So remember, when you have a logarithm, to rewrite it in exponential form, you start with the base, which is 4, and you raise it to what the logarithm is equal to. So 4 to the third power equals the argument, 3x minus 5. And then you just solve whatever you're dealing with. So 4 to the third, hey, we can figure that out. That's 4 times 4 times 4, which is 64, equals 3x minus 5. And now you just got a linear equation. Let's add 5 to both sides. So you got 69 is equal to 3x, and then we divide both sides by 3. And that gives me x is equal to, now 69 divided by 3 is 23. But now here's the thing, you've got to check your result, because it is possible to get something called extraneous solution. So when you check it, I'm just plugging it right into the original. Log base 4 of 3 times 23 minus 5, is that really equal to 3? Now honestly, what I'm really looking for is that this is not 0 or a negative number. But if you want to go to the full-on check, which I really think is a good idea, let's evaluate it. So that'd be log base 4, 3 times 23, is 69 minus 5 is 64. Is that really equal to 3? Well, two ways you can handle it. You can use the change of base, and you can find the natural log of 64. Remember, base on bottom divided by the natural log of 4. And that does give you 3. Type it in your calculator. Or, look, 64 can be written as a base 4. So log base 4 of 64 is going to be 4 to the third, and those cancel, and that gives you 3. And you check it that way. Okay, so make sure you check logarithms. You do not have to check exponential answers, but you must check logarithm answers. All right, next problem. 3 plus 4, natural log of 2x is equal to 15. You got to isolate the logarithm. Look, there it is. Found it, right? So that means I got to get that 3 on the other side so I can get my logarithm by itself. So I'm going to subtract 3 over. That gives me 4 times the natural log of 2x is equal to 12. When I subtract by 3, subtract 3, right? The logarithm's still not by itself because it's got a 4 being multiplied. So let's divide both sides by 4. Now I have the natural log of 2x is equal to 3. Okay, now the logarithm is by itself. What do? Well, you know that natural log is the same as saying log base e of 2x is equal to 3. So I start with my base, which is e. I raise it to whatever the logarithm is equal to, which is 3, equals the argument 2x. Remember, your goal is just to get the x by itself, so let's divide both sides by 2. And there's your answer. X is equal to e to the third divided by 2. And you can type that in your calculator, because remember, e is, you have to hit second natural log, and that'll give you e. I have to close out parentheses, so e to the third is like 20.085, but it's still have to divide by 2. So it's approximately 10.043, if I stick to the convention of rounding 3 places. Okay, that's my answer. Now when I check that, honestly what I'm really looking for is that when I plug that value, and you could plug the exact value or the decimal value into my logarithm, I don't get a negative number. Y'all, this isn't a negative number. But you could take it a step further and simplify. These 2's cancel. So again, this is the check. All I'm doing is the check. So I have 3 plus 4. You have natural log of e to the third. Remember, natural log and e cancel each other out. So I have 3 plus 4 times 3. Remember, the 3's still there. That's 3 plus 12, which is 15. So it checks out completely. But really, I'm just making sure I'm not taking the logarithm of a negative number. Continuing with our logarithm problems. Here we have two separate logarithms. That's not going to work out. We need to combine those together. And remember the condensed problems? This is exactly why you learned to condense more than one logarithm. If they have the same base, then you can write that as one logarithm, log base 2. Okay, now when you're adding, that turns into multiplication. So this is x plus 3 times x minus 3 equals 4. So these are equivalent equations. Now what do? Well, now the logarithm is by itself. So I say 2 is my base, raised to the 4th, equals x plus 3 times x minus 3. Now this is factored, and normally when something's factored, it's great. If it's equal to 0, this is not. So 2 to the 4th is 16. Let's FOIL it. So that's going to be x squared minus 3x plus 3x minus 9. Of course, those cancel. So I have 16 equals x squared minus 9. Going to subtract 16 on both sides. So I have 0 equals x squared. And then that's going to be what? Minus 25. Now, that factors, doesn't it? That 0 equals x plus 5 times x minus 5. Set each factor equal to 0, so that gives me negative 5 from the first factor, positive 5 from the second factor. You want to just circle them and move on, but you got to check it. Look, y'all, if I take negative 5 and I plug it in right there, that's going to give me log base 2, watch this, log base 2 of negative 5 minus 3 of negative 2. I can't do that. Negative 5 is out. But if I take 5 and plug it in there, that'd be log base 2 of 8. If I take 5 and plug it in here, it'd be log base 2 of 5 minus 3 is 2. That can be simplified and it will give you 4. But more important is that it doesn't give you the logarithm of negative numbers. So this guy checks out. If you want to check it all the way through, you can, just to make sure you did it right. But checking for extraneous solutions, once you know you don't have a negative inside a logarithm, you're good to go. All right, here we go again. Notice we have two logarithms again. We must condense and write this as one logarithm, okay? Remember, subtraction means division. So this is log base 3 of x minus 1 in the numerator, x plus 2 in the denominator, equals 2 on the other side. Now it's time to rewrite this in exponential form. So I start with my base 3. The logarithm is always equal to an exponent, so 2 is my exponent, and the argument, this rational expression, goes on the other side. Now we know 3 squared is 9, so 9 equals x minus 1 over x plus 2. How do you solve an equation like this? You've got to multiply both sides by the denominator to get that x plus 2 out. Those cancel. Now on the left, I distribute the 9 inside, so that's 9x plus 18. And on the right, I've got x minus 1. What do I do now? Let's subtract x from both sides. Why? I need all those x's on one side to be able to solve. So that is 8x plus 18 is equal to negative 1. Now what? Let's divide both sides, subtract both sides with 18. So now I have 8x equals to negative 19. Divide both sides by 8. And x is negative 19/8. Now what happens, y'all? If I take this and I plug it in right there, a negative number minus 1 is a negative number. Oops. No good. That answers out. You know what? That means I have no solution. Is that okay? Sure is. It'll happen, right? It's not because the answer is negative. It's because when you take it and you plug it into the logarithmic expression, it makes it negative. Now, if you plugged it in here, it might not be negative. Actually, it'd be negative here too, but if it makes one of them negative and one of them not, it's still not a solution. It's got to work for the entire equation. Now look at this. I've got all kinds of logarithms going on here. We do need to condense. This is subtraction, so you know that turns into division. So natural log, x plus 4 goes in the numerator, x plus 1 goes in the denominator, and I have a natural log of x on the other side. Now, you can write this in exponential form, but let me show you something. Because you have a natural log on the left and a natural log on the right, it must mean the insides have to equal each other. That's the only way this would be true. So you can ignore the natural log and say x plus 4 over x plus 1 must equal to x. Now, if you attempted to write this in exponential form, remember this is log base e, I would say e to whatever the logarithm is equal to, natural log of x, is equal to the argument x plus 4 over x plus 1, and these cancel each other out, and you get the same thing. Do you see what I mean? But really, if you have natural log on both sides, has to be on both sides, you can ignore the natural log and solve the inside. Now I'm going to erase this over here on the right because we ended up with the same thing trying to write it in exponential form, although it is a little bit confusing to do that. Now, to solve this equation, just like we did a minute ago, you can't solve for an x when it's in the denominator. So I must multiply both sides by the denominator. On the left, it cancels, and I get x plus 4. On the right, no fun, I get a quadratic equation because I have to distribute that x inside. And you know what I have to do to quadratic equations? You got to set them equal to 0. So I'm going to subtract x. That gives me 4 still on the left and x squared on the right because those cancel. Then I move the 4 over, so I have 0 equals x squared minus 4. Lucky for us, we got something that'll factor. X plus 2 times x minus 2 means I have two answers again. One of them is negative 2, and the other one is positive 2 from here. Now, do they both work? Well, the negative 2 plugged in here, so let's take it and plug it in here. It works okay. Negative 2 plus 4 is 2. But look, negative 2 plugged in here gives me negative 1, so it's out. But now 2, on the other hand, works just fine, because that'd be natural log of 6 minus natural log of 3 equals natural log of 2, and you can check it, and I promise you those are equal to each other. So one solution on this one. We got one more of these to do. Last problem, number 19. You've got log base 4 of 2x plus 1 equals log base 4 of a lot of stuff. Now, here's what I want you to notice. There's log base 4 on both sides. You remember what I could do from the previous problem? I can just set the inside, 2x plus 1, equal to the inside over here, which is x minus 3 times x plus 5. Only because there's a logarithm on both sides. You could also rewrite this in exponential form. If you did that, I'm going to do it in pink and then erase it. You'd have to start with your base, 4. The answer is a log, your exponent's the logarithm on the other side, so log base 4 of all that in parentheses equals the argument, which is 2x plus 1. Now what happens is these cancel each other out, and you still get x minus 3, x plus 5 equal to 2x plus 1. It's just faster to realize there's a logarithm on both sides, and you don't have to do all that. Now, this is a quadratic equation. We worked on these quite a few sections ago, but I need to FOIL this out and then get it equal to 0. Okay, so I've got 2x plus 1 equals x squared plus 5x minus 3x minus 15. Add like terms. So now I have 2x plus 1 equals x squared plus 2x minus 15. Got to get it equal to 0. Look, if I subtract 2x on both sides, 2x's are gone. So the 2x's are gone on both sides. And here we go. We've got 1 is equal to x squared minus 15. Let's subtract 1 on both sides. And that gives me 0 equals x squared minus 16. Okay? Then this will factor. So you have 0 equals x plus 4 times x minus 4. You recognize that as a difference of squares, right? It gives me x is equal to negative 4 and x is equal to positive 4. I want to circle them and move on, but I can't, right? I need to check these. Now look, if I take negative 4 and I plug it in right here, that'd be 2 times negative 4 is negative 8. Negative 8 plus 1 is negative 7. The log of -7 is not going to cut it, right? You cannot take the logarithm of negative numbers. On the other hand, 4 is okay. Now, not because it's positive, but if you check it in all these logarithms, here that'd give you the log of 9. That's okay. And then here you would have to multiply, you'd have to plug in the 4 minus 3, which is 1, times 4 plus 5 is 9. That'd be log of 9. So we know it's okay there by just checking it in each one. So that wraps up the logarithms. I hope you got a lot out of this. Please let me know if you have any questions. Have a good one.